These are the newest images of 3I Atlas captured just yesterday. And honestly, what they reveal might be the most shocking twist we've seen so far. Because up until this point, every piece of evidence was pointing toward one conclusion. This object had to be breaking apart. It was the only explanation that made sense. But these fresh observations overturn everything, and the reality they reveal is far stranger than anyone expected. So in this video, I'm going to walk you through exactly what is going on, starting with why scientists were almost certain this thing was fragmenting in the first place, and then we'll break down what the latest images actually show and why they throw every prediction off balance. Let's rewind to November 9th. That's when telescopes captured images of 3I Atlas showing a dramatic tail stretching millions of kilometers, along with a second tail pointing toward the sun. Now, comet tails form when gas escapes the surface. But here's the weird part. Cometary gas only flows out at about 1,500 kilometers per hour, which is incredibly slow compared to the distances these tails were spanning. For a tail to grow millions of kilometers long at that speed, the comet would need to be venting gas continuously for months. But just a few days earlier, images showed absolutely no tail at all. Nothing. That sudden, explosive appearance of massive tails made zero sense. And then came the size problem. For 3I Atlas to produce tails like that, calculations showed it would need around 1,600 square kilometers of active surface area absorbing sunlight. That's the equivalent of a perfectly round body about 23 kilometers wide. But Hubble had already measured the nucleus, only 5.6 kilometers across. That means the required surface area was 4 times larger than the comet itself. That math doesn't just not add up, it breaks the calculator. So astronomers took the next logical step. They estimated how much material must be leaving 3I Atlas to form these enormous structures. The result was almost unbelievable. The tails appeared to contain enough dust and gas to imply the object was losing around 50 billion tons of material every single month. But 3I Atlas itself weighs only around 33 billion tons in total. In other words, it was supposedly shedding more mass every month than it physically contains. That is impossible unless the object is not a single object anymore. And there's precedent for this. Comet Shoemaker-Levy 9 did something similar in 1992 when it broke into 21 fragments. Up close, it appeared to be releasing far more material than its original mass should have allowed. But the extra exposed surface area of all those fragments made sense of the data 7 bright, powerful jets were observed from 3I Atlas on November 8th. Massive dual tails appeared on the 9th. And the mathematical contradictions pointed to one logical conclusion. 3I Atlas had to be fragmenting into multiple pieces. For weeks, that explanation seemed unavoidable, until the new images came in. On November 11th, astronomers David Jewett and Jane Liu aimed a powerful telescope located in the Canary Islands directly at 3I Atlas. When they published their findings, the title alone stunned researchers. 3I Atlas still single. According to their analysis, the object was not fractured, not surrounded by debris, and not shedding visible fragments. It was, shockingly, still one intact body. But their conclusion wasn't based on a quick look. They performed a deep analysis of the environment around the object. 3I Atlas was sitting about 1.5 astronomical units from the Sun, roughly 214 million kilometers, and about 2.1 astronomical units from Earth, around 320 million kilometers away. They imaged and examined a gigantic region around the comet, nearly 500,000 kilometers wide, specifically looking for fragments, debris, clouds, or any pattern that suggested breakup. What they saw was a single, bright nucleus surrounded by a large, active coma. The glowing cloud of dust and gas that forms around energetic comets. Inside that coma were complex features, multi-layered structures, and swirling patterns. And yes, they confirmed both tails. One pointed almost perfectly toward the Sun at around 106 degrees, while the Sun sat at about 115 degrees. With only a 9-degree difference, this created what's known as an anti-tail, a rare but occasionally observed phenomenon. The second tail stretched outward in the normal direction at around 301 degrees, To search for fragments, they used every advanced image processing technique available. Brightness stretching, contour mapping, false color layering, radial analysis. All methods designed to reveal tiny structures hidden inside the coma. If even small pieces had broken off, these techniques would have picked them up. But the astronomers wrote explicitly in their report, there was no hint of fragmentation anywhere within the imaged region if 3I Atlas had broken into the 10, 12, or even 16 pieces that the math suggested it should have. Those fragments would be visible. They'd drift apart, they'd leave faint trails, they'd distort the coma. But none of that happened. Instead, we're left with a single, solid object that should have split apart weeks ago, but somehow didn't. And here's the craziest part. 3I Atlas made its closest pass to the Sun on October 29th, experiencing extreme heating and massive thermal stress. This is the point where comets often crack or explode from internal pressure. The amount of gas venting from its surface should have torn it apart. Yet 2 weeks after perihelion, it's still intact and firing giant jets in multiple directions like nothing happened. So now scientists have a huge problem. If 3I Atlas is natural, which remains the most reasonable assumption, then how is its survival even possible? Several theories are emerging. One idea is cosmic ray hardening. 3. I Atlas likely formed long before our solar system existed, maybe 7 to 10 billion years ago. That means it has spent unimaginable spans of time drifting through interstellar space, being bombarded by high-energy cosmic rays. Over billions of years, these particles could have altered its surface chemistry, creating a hardened outer shell. The James Webb Space Telescope discovered that 3I Atlas has 8 times more carbon dioxide compared to water than typical comets. That unusual chemistry could be the result of cosmic rays converting carbon monoxide into CO2 over billions of years. This crusty, radiation-modified layer might make the ice underneath sublimate in strange, channeled ways that create massive jets without requiring large, visible surface areas. Another possibility is that we're underestimating how much active surface area the comet actually has. It might contain internal pockets, tunnels, or porous structures that allow gas to escape through vents hidden below the outer crust. In that case, it could have far more sublimation area than the outer shape suggests. And then there's the idea that our mass loss calculations might be off, at least for this object. The 50 billion tons per month estimate is based on tail brightness and length. If the dust particles in the tail are unusually efficient at scattering sunlight, the tails could appear far more massive than they truly are. The bottom line is that 3I Atlas is doing things no comet or interstellar visitor has ever been observed doing. It's producing enormous, complex activity without showing the damage that activity should cause. It's defying every model we use to understand comet behavior. And as more data comes in, it's becoming clear that this object may force us to rethink what we thought we knew about interstellar bodies. If you stayed to the end, drop a like and subscribe for more updates. Because whatever happens with 3I Atlas next, you don't want to miss it.